Okay guys, so this is the question. Ax square plus bx plus c is equal to 0 and the roots of this equation are sine theta and cos theta and we need to find b square. Now when it says the roots are sine theta and cos theta, what this means is x is equal to sine theta or x is equal to cos theta. Now if x is equal to sine theta, is sine square theta plus b sine theta plus c is equal to 0. So what we're doing is we're basically just substituting x here with sine theta. And if x is equal to cos theta, then obviously a cos square theta plus b cos theta plus c is equal to 0. So we can call this equation 1 and we can call this equation 2. So if you guys don't know already, there's a very cool trigonometric identity where sine square theta plus cos square theta is equal to 1. And if we want to apply this identity to solve the equation, the only way of bringing sine square theta and cos square theta together is by adding equation 1 plus equation 2. So this part is equation 1, this part is equation 2, and since both are equal to 0, they'll obviously be equal to 0. But you can see that we have sine square theta and cos square theta in the same coefficient, sine theta plus cos theta in the same coefficient, and c plus c in the same coefficient because they're the same variable. So if we want to use this, then we can just arrange the terms like this, where things with the same coefficient are put together, and we can take a common here, we can take b common here, and we can add these two variables c here. It looks something like this, and we obviously know sine square theta plus cos square theta is equal to 1, so we can express it like this. And you might think since we need to find the value of b square, we can equate all of this in terms of b, but actually that would be a bad idea, because if we equate in terms of b, we have this sine theta plus cos theta term here, and we want to find the value of b. So to find the value of b, we have to express everything in terms of sine theta plus cos theta, and this will be very obvious in the next step. So this is what it looks like. This is what it looks like when we express sine theta plus cos theta and equate everything according to this. And this is our first step, equation 1 plus equation 2. But what if we do equation 1 minus equation 2? So this is what it would look like. This is equation 1, this is equation 2, and since there's a minus sign here, everything here will just become minus. So if we remove the bracket, it would look something like this, and we can bring terms on the same coefficient together so that we can take common here. Now this equation, and also if we take common and we make sure to do operations with the same variable, then obviously this and this cancels out. We can take a common here, we can take b common here, so we get something like this. Now this equation might look very stupid because there's no trigonometric identity for sine square theta minus cos square theta, but if you know anything about a square minus b square, it's just a plus b into a minus b and then the rest of the equation. And if you're a very mathematical person, you can see that sine square theta minus cos square theta is common, and if it's common, then we can actually divide it. And since this is all equal to 0, it won't really make a difference. So in fact, we can do something very cool. We can just divide it from this term over here, divide it from this term over here. This will be 0 divided by sine theta minus cos theta, which is still 0. So we get an equation like this, and we can finally equate in terms of sine theta plus cos theta again, which would give us this. Okay guys, so I'll explain what we have done till now. Basically, we have two equations which are both equal to sine theta plus cos theta. So minus a minus 2c by b is equal to sine theta plus cos theta, but minus b by a is also equal to sine theta plus cos theta. And since they are both equal to sine theta plus cos theta, they are also equal to each other since they both equate to sine theta plus cos theta. Now, if you guys still remember what we have to do, it is to find the value of b square theta in terms of a and c, and we have an equation that's literally perfect for this, because if we cross multiply b here and a here, something like this. Now we have minus b square theta, but if we divide by 1, we should get the value of b square theta. These are both minus, so we can just put this in the bracket and this becomes plus, because then we're just reverse engineering this, and now we can cancel minus on both sides, and we get b square equals to a square plus 2ac. Thank you for watching.